for more on the phenomenon, we can bring in Jean-Pascal Van Ypersele, a professor of climatology and environmental sciences at the Université Catholique in the Belgian city of Louvain. Good morning, and thank you so much for taking the time to speak with us.
You're welcome.
We heard a bit in that report, but could you perhaps explain in your own words and a bit more detail exactly what El Nino is?
So it's as your diagram showed, your animation showed, the winds above the tropical Pacific are usually pushing water from east to west in the Pacific. Around Peru, usually the winds push the water away towards the west, towards Australia. But when an El Nino event starts, those winds start to weaken. They start to become less strong. And that means that the warm water that is usually pushed towards the west is not pushed as fast towards the west, and at some point even comes back to the east. So you have a warming, a temporary warming, which lasts a few months, up to a year, in the eastern part of the Pacific, that is west of Peru and South America. And that warming of the surface of the ocean there has important consequences, both on the global temperature and on the movement of rainfall patterns. Because when the ocean is warm, it evaporates a lot of water vapor and it facilitates intense rain and intense precipitation. So when there is an El Nino, you typically see in the western part of South America, around Peru, for example, very intense rain. And on the contrary, because the rainfall patterns have moved from west to east in the Pacific, you see typically drought, or at least the probability of drought, increasing around Australia, Indonesia, and in the western part of that Pacific belt. But the El Nino event also disrupts the general circulation of air masses, particularly in the tropics, and it has consequences in Africa as well. For example, typically in the Horn of Africa, you see more rain during an El Nino event, and so it's a phenomena that at the same time increases the global temperature average and has important local and regional effects on the side of extreme events, droughts in certain areas, and intense rain and sometimes floods in other areas.
And do we know anything about what causes El Nino? I mean, what causes those winds to suddenly weaken?
Well, it has been the subject of research for a long time, and we don't have a definitive answer. What we know is that it's related to an interaction between the atmosphere and the ocean, and there are feedbacks. The atmosphere is influencing the ocean, and the ocean in reverse is influencing the atmosphere. There's a kind of vicious circle happening at some point. But what starts an El Nino as is not fully understood up to now. What we know, what we suspect very strongly at least, is that the global warming, which is not causing El Ninos, we should be clear about that, because there have been El Ninos for centuries, but global warming is aggravating the impacts of El Ninos when they take place. For example, because warming causes the atmosphere to be richer in water vapor. So when there is intense rain associated to an El Nino event, that rain is even more intense because of the El Nino. So El Nino is a kind of amplificator of the effects of global warming.
And has this most recent El Nino event already begun? I mean, are we already seeing its effects in these current heat waves we've been seeing in the US and in Europe as well?
Well, there is a heat wave in Europe and the US for sure, but we cannot attribute that to El Nino. El Nino typically has effect in the tropical belt around the world. What we see in Europe and in the US is essentially the effect of global warming itself, but it's not an immediate result of El Nino. The effects, they're called teleconnections because the connections on a long distance between El Nino and what is happening in the weather elsewhere on the planet mostly limited to the tropics. But what we see in Europe now is clearly amplified by the global warming itself, but not by El Nino, most likely.
And you mentioned some of the regions that are likely to be the most impacted by this. Could you say a little bit more, perhaps, about what effect we expect it to have and also how governments can be preparing?
Well, we are likely to see a higher risk of droughts in part of Australia and Indonesia, as I mentioned, Central America, Northern South America, and Southern Asia. And on the other hand, we're going to see a higher risk of rain and floods risk in part of southern South America around Peru, the southern part of the US, the Horn of Africa, Kenya and Tanzania and that part of Africa, and Central Asia as well. So its probability is increasing of those extreme events, and the advice to governments and citizens is to prepare as much as possible, to increase preparedness, to make sure that warning system, that weather forecasting system are up to date, because it's important for agriculture, for example, to have warning of what might happen. It's important for water management. It's important for health systems, and disaster preparedness in general is important, but is even more important when there's an El Nino situation. So everybody should prepare for more extreme events on the weather side in the coming months in the tropics.
El Nino also has an opposite weather phenomenon known as La Nina. Can you explain how La Nina functions, and then is one of those likely to follow this El Nino?
La Nina is exactly the opposite of El Nino, and you can actually mirror everything I said about El Nino, and La Nina is the reverse of El Nino, and so when there is a La Nina, which indeed very often follows after a few months after the end of an El Nino event. But not always. I mean, it's a difficult animal. El Nino, La Nina, phenomena that are not fully understood at the moment. But usually there's a La Nina event, which is the inverse of El Nino, a few months after La Nina, and then you see the reverse. I mean, you see more droughts in East Africa, for example, and more droughts in the western part of South America, and you see floods in Indonesia, for example, or a risk of floods in Indonesia. It's really the reverse of El Nino.
Recent weeks have been full of climate stories with these heat waves and these wildfires. And I just want to finish by asking you, as a professor of climatology and the environment, what's your feeling been like as you see what's happening?
Well, I've been working on this for more than 40 years now, and it is sad, I must say, because what is happening is almost exactly what we warned about 40 years ago, even before the IPCC was there. And policymakers have not listened enough to the warnings of scientists. Now, it's not too late to start to act to reduce greenhouse gas emissions, to reduce our dependency on fossil fuels, because if we don't do that, the impacts of climate change will become even worse in the coming decades. And that is the saddest of all, it's our kids and small children who will suffer even more than those who suffer today.
Now, hopefully this latest wake-up call will finally be heeded. Jean-Pascal, thank you again so much for taking the time to speak with us this morning. That was Jean-Pascal Van Ypersele, a professor of climatology and environmental sciences at the Université Catholique de Louvain.